All right, I think we're good to get going here. Appreciate everyone's patience while we let people roll in here as we get started. I'm Kevin Cutter. I work as a cybersecurity and compliance advisor for Tevora. I'm joined by Chris Callis, Tevora's Director of Cloud Security. And today he's going to be talking about our webinar session, Tackling the Security Challenges of Modern Cloud Operations. At the end of the webinar, know that your respective rep, myself included, will be following up with Chris's webinar deck as well as the recording links. So if you find interest and traction from today's session, please feel free to share this among your teams. And we're excited to have you. So with that said, I'll turn you guys over to Chris and we can get started.
Hey, thanks Kevin for the introduction. Can you give me a thumbs up? You hear me okay? Because I can't hear anything. All right, perfect. Don't want to cause a little like feedback loop. Anyways, my name is Chris Callis. I am, as Kevin said, I oversee our cloud security program. Glad you guys could take some time to hang out this morning, afternoon, just depending on where you're at. All right, so last year during our Modern Cloud Operations webinar, we spoke about this generational shift that is occurring where organizations are moving from static to dynamic infrastructure. Today, we're going to continue to build on those concepts, but just in case you wanted to catch up, you could click here, which this is for when it goes up on YouTube later on, where we'll be having our office hours as well. But you could click here and hopefully we'll get the webinar wherever that finger's pointing, but around here somewhere, who knows. So really, I felt that the best way to start this prevention vendor lock-in stream was really to recommend 9 vendors that will help you in not getting locked into a particular vendor. How's that sound? I'm just kidding. So, we're going to do this webinar this week. Like I said, or my LinkedIn and stuff like that will be included at the end, and we'll be doing office hours and having deeper discussions. But like Kevin said, we'll do a brief Q&A after as well, and we could break out into the conversation if you guys wanted to dig into it a little bit more. So with that said, let's go. Perfect. So in this new dynamic world, security, operations, networking, and developers, we're all facing different challenges based on their own business requirements. But when boiled down, there are a couple core similarities that exist, and this gives us a great area of commonality to kind of start this journey. So we know that code collaboration is a huge driving force for adoption. With this increased complexity in our environments, it's difficult for a single person to reason about the environment alone. Collaboration provides checks and balances, keeps teams on the same page, and version-controlled infrastructure drastically helps manage security and compliance. So it's pretty clear from here that we want to be codifying everything. But really, what does it mean? And it means to capture a routine, process, or configuration. Done. We're going to codify all the things. But that is the base at which we will start. But before we go any further, you will find that whenever we build with the intent of the workload being immutable. And that means we can delete it, we can restack it, and we can keep on doing that over and over again without fear of loss of data, but having fresh systems. And really the last core requirements that we're going to be laying out before we really dig into some of these processes when we're planning for new environments is that we use a solution that allows us to have declarative code. And that means that we specify the desired state. It's generally human readable, and that's as opposed to being, its counterparts, imperative code, which is very procedural based, your C#, your Javas, those type of things. And really this whole concept of declarative code is really what's going to future-proof you. And I don't like using terms like that, just out of nowhere. The reason it's going to future-proof you, and we've seen it here at Tevora firsthand, is we spent a considerable and a significant amount of effort internally training the other towers. And we joke it's just around the corner, but it's really something that a lot of these organizations are practicing today, even if everything is not entirely codified, right? And when we're taking a look at a typical cloud security review that we're doing, well-architected review, a cloud compliance review, if we peel back the layers and go back a couple of years, we used to, and we still do, log into an account. You're going through and you're taking a look at the controls. You're aligning them with roles and responsibilities, seeing what's in place and what's not in place. And this is good, but the output of the reports may not necessarily reflect how you operate, right? And that's why it's important. And that's why we're focusing on bringing our teams up to the code level, right? So they can understand, they know what to expect, and that helps them gauge into the drift that may occur when they're actually doing the assessments. So just wanted to give a little brief dive into why having declarative code is so important, because you don't need a programmer to sit in front of it, right? You can generally read it and understand what it is doing and then validate it based on, a run or simulation that you're going to be doing. So now that we talk about codifying, what are some of the vendor locking risks that exist? So over the years, we have found certain core areas, when people are making this journey, they can really slow an organization's ability to really achieve that evolutionary architecture, right? They could spend more time kind of rebuilding the latest and greatest technology, but there's not really a common foundation that exists. So really the first part of that from a vendor lock-in risk is really understanding, roles and responsibilities. I think probably AWS probably has the best roles and responsibilities matrix that I have seen. If you log into your account, you click on artifacts, you can download their PCI DSS AOC. That's always a really fun read, when it's not sometimes. But what it does do is it doesn't just let you know what services are being evaluated and are covered under the latest ROC, right? But it also lets you know what your expected responsibility is within this shared responsibility model. And that's really the first place that you want to start when you are evaluating new technologies, because that's going to let you know whether, for example, when EKS first came out, these managed Kubernetes instances, everybody wanted to jump on it right away. But it not being part of the latest ROC or AOC kind of slowed that development process down a little bit. But if organizations didn't check those roles and responsibilities, come compliance time, they potentially could have had some issues in terms of leveraging some of these technologies. So that's my little roles and responsibilities rant. Whether you're in a major cloud service provider or if you're using a SaaS platform, it's really important, especially if you have compliance obligations, to request those AOCs, those SOC 2s, really dive in, but also kind of critique the intent of those things. A lot of the times on a SaaS side of the house, you'll see that it'll talk about managing access, but there's no details about the hypervisors that are being used for the Docker images that are getting spun up for your pipeline testing. What's going on with any of those secrets? What if the client segmentation exists? We know it's SOC 2 compliant, but it's a lot of conversations that we have and help our clients have in terms of evaluating new technology. Another risk is, during initial phases, we find organizations tend to virtualize technology that they are familiar with. The issue is you start to walk a fine line between the native efficiencies that you just gain when moving to the cloud, which are defined by those roles and responsibilities I just ranted a little bit about. And it starts to increase the complexity in the efforts in evaluating the security controls if the right questions are not being asked. Next one has to do with networking. Over the last couple of years, we've seen organizations change how they operate. They've gone from either a single AWS account, they've grown it to have multiple VPCs within the AWS account, to having those roles and responsibilities shift and change to having the statement of, hey, the greatest form of segmentation that exists is at the actual account level. So they start spending time developing these landing zone concepts, and all of a sudden, next thing they know, is they've gone from a single account to 2,000 accounts, and it's only been a year. So, when you're coming in and you're doing like a review or an audit, like what do? Do you just increase effort by 200%? That's not going to scale, right? At some point. So just some considerations to keep in place. So when we're talking about some of the networking challenges that exist, there's a couple of core challenges. One, we're talking about scaling, being able to scale it exponentially. The next is, hey, how are you going to be monitoring for compliance? Have you adopted your model to include service discovery and routing? For example, in PCI, having an accurate inventory in the cloud has been a hot topic, especially with organizations that treat their systems as being disposable and cycle them on a weekly basis. You may have had a finding during the assessment window, but that system that you just wrote down no longer exists. How do we validate that those security controls are now in place? How do we even reference a system that's, immutable? It's been interesting, but the answer is no. So we know in the multi-cloud world, we want to consume services. Maybe we want to use a VM in Azure for compute and S3 for storage within AWS. You start getting into things like setting up, private links between the environments. And whenever you're setting up these links, you can take a look at any of the documentation. It starts getting pricey really, really quick. And I just saw the GoToWebinar disappear. Okay, it's still going. We are good. We are good. Wasn't sure if it crashed. Anyways, so this is where we start looking into services that provide, service mesh type capabilities. And this generally means leveraging technology that allows for service-to-service connection, authorization, and encryption, leveraging mutual TLS connections. And this starts to solve the question of ensuring that there is parity also between your environments. The next thing has to do with secrets management. And no, not LastPass or OnePass. We're talking about Azure Vault, AWS, KMS. These are amazing services. Gone are the days of hard coding sensitive variables within your configs. Now everyone just calls parameters, right? There's no hard coded variables anymore that exist. Although technology has been a blessing, there are a couple of risks with these native solutions. For example, when you want to start to explore how to get your secrets and keys outside of AWS because the organization has just started to prioritize Azure this year, how are you going to be able to do this? And this is a huge topic when we're talking multi-cloud, whether it is to diversify and spread risk, or maybe have your customers who are closer to certain edges based on the available service provider. It's something that's coming up more and more during our discussions. So in this world, an application makes a request. Typically, it provides credentials, and hopefully, just the requested information is what is presented. And in the world of the cloud, what you want to be able to do is authenticate the identity against some type of trusted source. But before granting access to the systems, you want a platform that is dynamic and can provision against an identity model that you care about, any identity model that you care about, really. You want that flexibility so you can get into that well-architected evolutionary architecture. So since all apps are now coming through your newly selected secret manager that we just talked about, this enables us to do a couple of really cool things. First, it allows you to now enforce policies to encrypt all things that flow and that are stored. And it allows for the centralization of secrets and credential management. And so you're able to not only encrypt the data at rest and in flight, it's really built in to the new platform that has been built. This, coupled with mesh networking, starts to address many of your security and compliance challenges automatically. So as organizations get more and more advanced, things like storage and compute and networking start to shift from things that are static to things such as S3 and RDS into pools of infrastructure that are ready for consumption. So now that we have a pool of infrastructure, we have automatically baked in secret management. Now we pull in developers, right? Well, the developers are going to come to you with their Java apps, their C# apps, their container-based apps. So it's important to pick a solution that will handle scheduling for us across all of our newly architected environments. And you want to integrate this with all that has been built. This is easy since we spent that initial time implementing a secret manager that is flexible to handle the identity challenges. And we have a network design that allows us to pick where we want to deploy these apps based on security, privacy, compliance requirements, or region availability type concerns. And this flexibility starts to make all of this effort that was put into putting together this platform worth it. So now we're aware of some common considerations and issues. We have a plan. We're going to codify all the things, and we're going to make sure that we pick the right solution that fits into that Lego piece. So what else should we be thinking of? So we live in a world where tooling is no longer an optional thing, and there needs to be a strategy to enforce that consistency across these complex environments. And time and time again, you've heard me say it probably a million times by now in this webinar, is to codify the environment. And when I say that, and now we're going to dig into this a little bit more. So when we're talking about this, again, to reiterate, we're talking about capturing that routine, that process, that configuration in a way that is repeatable and scalable. So with this approach, there's an intrinsic layer of isolation that allows us to define our problem within our respective domain, very specifically. So the world doesn't need to be solved, just our tiny corner of it. And I joke about this with our clients all the time in terms of finding that Lego piece to fit the world's needs. But it's really what these cloud service providers have become. So once all the code has been captured and all teams are speaking the same language in a common format, we can then start to build these CI/CD pipelines to automatically build a workflow that works for collaboration. It provides sufficient segmentation and allows us to gain assurance, not only from a security perspective, but from a resiliency perspective. So now that these decisions have been made, what kind of things can you start doing, right? Linting is one of those things. Once all the code has been captured and defined, it allows organizations to enforce their own opinion on that code. And this is commonly done in the form of static analysis and alerting. And in this, organizations can go as little or as complex as they feel necessary, and that on that analysis of the code itself. And that linting allows us to version control it over time. And this has been super helpful with things like SOC 2, where you need to prove that the initial, a SOC 2 type 1, you're defining the controls that are in place, SOC 2 type 2, you're taking a look at ensuring that those controls are in place, seeing what's changed, but also, that there hasn't been drift. And linting has really allowed organizations to tackle this type of challenge. Another thing it allows you to do is start to threat model. There were times when we would do like PCI assessments, and you would get a diagram. The diagram was 5 years old, which was always interesting. So, and that's not an accurate reflection of what actually exists within the environment. So there's a little exercise that needs to be done. And that's generally how we started off a lot of those reviews. It's really understanding data flow, the current state, and having an accurate representation of the actual environment. Well, when things are done as code, one of my favorite things to do is be able to model the outputs. And that allows us to really take these abstract concepts like infrastructure and networking and put them into something that allows us to interrogate our decision. For example, Terraform is something we use quite a bit. It's immutable, and enable immutable infrastructure. It's also, declarative, so we can stick teams in front of it that may not be software developers and understand what's going on. And these type of tools allow you to export things within to an open-like file format. So now you don't have to spend time manually configuring these network diagrams. You could click and actually have a representation of what these environments look like. And let's see here. So we talked about the abstract modeling. Here's an example of some home IoT stuff that's been defined within Terraform, and salt stack at home, and then we can output it and visually see that, hey, this is where I have like managed thermostats. This is how the communications are actually flowing, and understand what goes on within your environment. And this is always a fun exercise to do. So with that, we can also start to do things like automated reasoning. And what is it? This is a really exciting field where services are mapped to math language. And it allows you to interrogate your configs with questions like, hey, is my database that lives in the private subnet actually accessible to the internet without sending a single packet of data through the actual environment? And and this is all done based on math proofs that a lot of these cloud service providers have put effort into actually developing, which has been really neat to kind of come through. And that allows us to start doing things like no longer sampling just 10% of the environment. Like, how much confidence do you have with that when the environment is scaled, from 1 to 1,000 accounts? Is 10% enough? Now that we have a common config, we can start leveraging these things to lint and layer in automated reasoning to start asking those compliance questions and getting those answers. And that's super exciting type stuff. We're also seeing this kind of like culture movement where mature teams are shifting their roles from putting out fires to causing fires in order to understand their environment weaknesses. Netflix used to call this, I think they still do call it, chaos engineering. They have a cool tool called Chaos Monkey. If you're brave enough to run that or have enough confidence to run that within your environment, that actually goes on to start taking down services to ensure that things are actually resilient and functioning. So definitely it's a pretty neat thing to test mature workloads against. And this allows teams to start gaining that confidence in the workload's ability. because the workload was designed to be scalable and repeatable and immutable. They start understanding, hey, there's no nuances, there's nothing lingering. And this type of consistency fosters confidence, when that means that you're no longer going to have these systems that are up and running for years on end. Potentially they've never been patched because you're scared that it's going to take down production, right? You don't have to worry about these things anymore because you're doing it all the time and everything is working, which is pretty neat to see, especially, on the Terraform side. You can do things like, hey, we've defined this infrastructure. If there aren't preventative controls in place, you can troubleshoot, you can modify things. And when you do your next run, it'll tell you exactly what has drifted and what it intends to change from out, or you want to update your code to ensure that it reflects those actual changes. So super, super exciting stuff. This also allows us, one last thing, to help organizations. We start setting up tools like TensorFlow for security operations. That's an open source tool, TensorFlow. It's pretty neat. Gone are the days of, hey, is it dog, not hot dog type thing that everybody jokes about from a machine learning perspective. What this is able to do, since your systems and your scale environments are scaled so exponentially, allows you to analyze logs, and it starts pointing out some of these needles in a haystack. So it doesn't just have you understand, it starts being able to identify things just based on a drift kind of like occurs, right? So you can start seeing risks that potentially exist within the environment. We also help out some of our clients do things like distributed tracing. There's a really cool open source tool called OpenCensus, which helps us understand flow from the internet to a microservice. So I don't know if any of you guys have ever taken a look at the VPC flow logs that AWS provides. I've been on a couple of calls where, hey, we're troubleshooting something, want to make sure it's not the security group that's preventing it from actually occurring, and you open it up and you're like, oh, everything's in epoch time. What's actually going on? And you need a way to actually digest these logs. And so OpenCensus is one of those tools where you can trace the flow from the internet to your microservices. And commonly it's used to find bad deployments of an actual environment, but we've also started leveraging it to start identifying potentially malicious activity within the environment as well. So that's it. That's all I got on my end. Again, my name is Chris Dallas. These are, a couple of tips to avoid vendor lock-in, going down the future. If you guys have any questions, here's my contact details. Keep an eye out on the LinkedIn. I think we're going to be hosting what is called like an office hours type thing here shortly, where it's a fun get together and just start talking shop and security architecture and challenges and understanding how organizations have seeing how different organizations approach different challenges, right? So with that being said, I will pass it over to Kevin, and thanks for the time.
Awesome, I appreciate it, Chris. It was a great session today, very informative. So as Chris was suggesting, and it's Tevora's real motto, to get our clients back. So we're going to do everything that we can to work with each of you, because each vertical has its own challenges. A different security stack is at a different place in their cloud maturity. So your respective Tevora rep is at the very least going to be providing the webinar recording as well as the deck from today's session. If you'd like to have a direct line to Chris, we can absolutely arrange that. You can pick his brain for any of your individual challenges. And then obviously we'll also be providing the YouTube link that he said. So we'll get that out with the deck and the recording, and any questions, just let us know. Otherwise, that's it for me, and have a great weekend.